Okay, here are your last few questions. Going back to the idea that when I have an angle with a vertex that's floating randomly in the circle, not at the center, I'm not only going to look at the angle in question, but I also consider that the vertical angle is congruent. So I'm going to look at the two arcs, the two intercepted arcs for both angles. The measure of this angle, measure of angle x, is going to be the average of the two arcs. So 50 plus 92 divide by 2. Remember to be careful with your calculator work. Either put the numerator in parentheses or hit enter after you do the addition. But once you do divide by 2, you should find the measure of angle x is 71 degrees. Number 7. Now we set up an algebra problem, but using the same idea. The measure of the angle, in this case, is 5x plus 14. Notice that they're giving us this angle, so be super careful here. Because what I can do is I can use these two arcs, not in direct relationship with the angle they're referring to, but in order to find these angles. So I'm going to start there. I know that these angles, the measure of this mystery angle, is equal to the average of those two arcs. 97 plus 35 divide by 2. So 97 plus 35, I'm going to get 132. Divide by 2 tells me that this is a 66-degree angle. Now, the reason why that's helpful is I can now acknowledge that I have a linear pair here. This 66-degree angle plus the 5x plus 14, together those should equal 180. They are a linear pair, and now I can use this to solve for x. So combine like terms, the 66 plus the 14, I'm going to get 5x plus 80 equals 180. Subtract 80 from both sides, I get 5x equals 100. Divide by 5 on both sides, I get x equals 20. And are they just asking for x here? Find the value of x? Yep, x is 20. Number 8. Start off with the formula. Once I identify where my sides cross the circle or intersect the circle, I have my two arcs, right? My vertex is on the outside, so I know I'm dealing with a different formula. This time, I'm going to say that the measure of the angle, this 38 degrees, is equal to the measure of the far arc, which is x, minus the close arc, which they told me is 72, divide by 2. Yes. And now I can solve for x. So something I can do is to get rid of that denominator, I can multiply both sides of the equal sign by 2. That gets rid of the denominator. And I'm left with x minus 72 on that side. And now on the left, I have 2 times 38, so that's going to get me 76. Now I add 72 to both sides to get x alone, and I get that x is 148. Okay, last problem, number 9. Again, our formula says that when I have a vertex outside the circle and I identify where the two sides are crossing the circle, I focus on my two arcs. I know that the angle measure is going to be equal to the far arc minus the close arc, divide by 2. So 28 degrees is equal to the far arc of 4x plus 8 minus the close arc of 3x plus 2. Divide by 2. We need to be real careful in this numerator here because I have to acknowledge that it's minus this entire expression of 3x plus 2. So I'm, in a sense, distributing that subtraction. So I have 28 equals 4x plus 8 minus 3x minus 2. And that's all divide by 2. I can combine like terms here. I have 28 is equal to, I have 4x minus 3x. So I have 1x. And then I have 8 minus 2, so that gives me 6. Don't forget that still divide by 2. Multiply both sides by 2 in order to get rid of this denominator. So 28 times 2 is going to give me 56. 56 equals x plus 6. I subtract 6 from both sides, and I finally find that x is 50. Okay, if you have any questions, let me know.